In this lesson, you will learn how to evaluate logarithmic functions. A logarithmic function is the inverse of an exponential function, so they are opposites of each other. We write them like this right here, where you have your log. This right here is the base. And then here you either have a variable or a number. We also have what we call a natural log. A natural log is written as ln of x, and it is the inverse of the exponential function e. The log is the inverse of any number. So this base here would be any number, whereas this one has to be an e. Here is a graph of a log function. You can see that it goes up like that, and we already covered exponential functions. It goes up and down. Do you see how they are opposites of each other? So you can evaluate logs by different methods. We'll start with just using a calculator, and then you're going to learn how to convert from log to exponential form. And you could use that method to evaluate this if you wanted. So you would go to your calculator and just type these in. So for here, you would put log of 100, which you will get 2. Same thing here. Here you would put log with your base of 9. If you don't have the calculator that has a little spot for this number, then you have to use what we call the change of base. And the way what you would put in is the log of 9 over the log of whatever your base is. This is called the change of base formula, and you will get 2. But you need to get a TI-84. If you have a TI-84 calculator, you would just do alpha window and then input that. Log of -6 does not exist. That's because logs cannot be negative. Same thing with natural logs. They cannot be negative. So this lesson here will just show you how to enter these in your calculator, and you don't always get a clean number. Like if you put in the log of 7, and we're going to round this to 2 decimal places, you'll get 0.85. But let's see how logs and exponential functions are inverses of each other. So say we have a function here of a log. If I want to get the inverse of this or write this in exponential form, you need to follow a pattern. You would write your base first, which is b. So here's my b. Then you write what's outside of your equal sign, or on the other side of your equal sign is what your exponent is, and then that would equal what's inside. So it's b to the y equals x. That's how you drop this, okay? The same way, if I wanted to go from exponential to that, add a log, then you put your base at the bottom, and then switch these two. If you have a natural log, you cannot use a number, you have to use e. This is important to know how to go back and forth, especially when we start solving. So let's do some examples. So here we're going to go from log to exponential form. Remember, you start with your base, which is that little number here. That's a 7. Then you put what's outside of your equal sign, which is 2, equals whatever's inside there, which is 49. So 7 squared is 49 is the same thing as saying log 7, 49 equals 2. Same thing here. You start with your base, which is an a, put whatever's out here, which is a -x, equals whatever's inside, which is an m. Okay, if you have a log and you do not see that small base right there, it is understood to be a 10. You are not going to normally see that. So you would need to know, if you see a log without a number, the base is 10, and then follow the pattern. So 10 to the third power equals 1000. Same thing with a natural log. If you don't, you're never going to see a base here, but you should know natural logs and e are inverses of each other. So the base of a natural log must be e. So you have e to 3.4012 will equal whatever's inside, which is a 30. So that's how you go from log to exponential form. Now let's go backwards and go from exponential to log. Start with, look at what your base is. If it's a number, write log first and then put the base. Remember, this is the base that's carrying the exponent, so that will go there. Then you see how the 3 is next to the 2, it would go on the other side. This time it won't be next to the 2, so switch that 9 and 2. The 9 is a big 9 and the 3 is like a subscript. For number 2, I have an e, so I have to use natural log, and you don't need to write the e. Normally you would write that in the base. We don't need to write that. You would just write ln, normally would be e, and then go to the outside, which is x, equals what's next to your base, which is 3. Here, this is a number, so I'm going to put log. We normally don't put a base of 10, so I'm not going to put it. So log 100 equals 2. This is a variable p. Unless it's e, if it's e, you use natural log. If it's anything else, you use log. So log, and my base is a p, a 3 equals k. That is how you go from log to exponential, exponential to log. This lesson is really important, especially when we get to solving, which we will go over these again and see how you can use them to solve log equations.